Ideal gas law. Describing a sample of a gas. 4 variables are needed to completely describe a sample of a gas: temperature, pressure, volume, amount, number of moles, of gas. Equation of state. An equation relating the macroscopic variables that describe some type of matter. The ideal gas law is an equation of state for gases. Boyle's law graphs. Volume versus 1/pressure. Pressure versus volume. Charles' law graph. Gay-Lussac's law graph. Avogadro's law. Recall SO V1/pxnxt Boyle's law, Charles' law, Avogadro's law. Vt, Kelvin. Vn, constant T, N, constant P, N, constant T, P. SO V1/pxnxt. Ideal gas law. To turn a proportionality into an equation, insert a constant, V equals RNT/P. Or multiply both sides by P. PV equals nRT, where R is the ideal gas law constant. If 3 of the variables are known, the 4th can be determined. The units of R depend on the units used for P, T, and V. Units of R. 2 common values of R: 0.08206 literage, 8.314 joules or 8.314 litre. Molic. 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 Problem solving. Most commonly used value of R: 0.08206 literage. Note: pressure must be in atm. Volume must be in liters. Temperature must be in kelvins. Molic. Ideal gas law problems. What pressure is exerted by 0.75 moles of a gas at 25 C in a container with a volume of 1.5 liters? Find the volume of 0.85 moles of gas at a pressure of 520 torr and a temperature of 15 C. How many moles of gas are present in a sample at 700 torr, 333 C, and occupying a volume of 452 milliliters? Extensions of ideal gas law problems. PV equals nRT. N equals mass. Density equals mass. Formula: mass, volume. Memorize the 3 fundamental equations. Substitute and rearrange as problem demands. PV equals nRT or PV equals mass. Rearrange to solve for mass or density. Formula: mass equals mass/volume equals density. Formula: mass, volume. RT. Formula: mass, identity of gas. Formula: mass equals mass, or formula: mass equals density. PV. P. Density of a gas at STP. Density of a gas equals molar mass/22.4 liters. This is an easy relationship, but it is only true at STP. Dalton's law of partial pressures. Dalton's law of partial pressures. For a mixture of gases, tot equals P1 plus P2 plus P3 plus. The total pressure of a gas mixture is the sum of the partial pressures of the component gases. The pressure exerted by each gas in an unreactive mixture is independent of the other gases in the mixture. Additional subtraction problems. 3 gases, He, N2, and R are present in a gas mixture. The partial pressure of He is 360 torr, of N2 is 400 torr, and of R is 250 torr. Find the total pressure. R is added to the above mixture until the total pressure is 1200 torr. Find the new pressure of the argon. Collecting gas by water displacement. When the water levels inside and outside the inverted container are the same, the total pressure inside the container above the water is equal to the atmospheric pressure. Sometimes gases are collected by water displacement. C2H2G plus H2OG. Line up the water levels. Tot equals gas plus water. The volume of gas collects above the water, but some of the water molecules evaporate and go into the gas phase as well. The vapor pressure of water depends only on the temperature. Look it up in a reference table and then subtract it from the total pressure. Extension of Dalton's law. Since PV equals nRT, then Tot equals nTotran for each component, Bi equals NOT. Bi equals NOT/V, which reduces to pi. Tot equals Ni, nTot. V. Tot nTot/V. Mole fraction Ni, nTot is called the mole fraction equals I. Bi equals Ni, nTot tot. Effusion. Gas. Vacuum. Effusion. Process where molecules of a gas confined in a container randomly pass through a tiny opening in the container. Rates of effusion can be used to determine the molar mass of a gas. Kinetic energy of molecules in a gas depends only on temperature and equals half mv2. Effusion. Two gases at the same T have the same average K. Half m1v12 equals half m2v22. Note, this V is the velocity of the molecules, not the volume of the container. V12 equals m2. V22 m1. Effusion. Two gases at the same T have the same average K. Half m1 v12 equals half m2 v22. Graham's law of effusion. The rates of effusion of gases at the same pressure and temperature are inversely proportional to the square roots of their molar masses. The heavier gases move more slowly. Effusion. Recall, the faster you are going, the less time it takes you to get somewhere. Diffusion. Gradual mixing of two or more molecules due to their spontaneous, random motion. Gases are in constant, random motion and tend to move from regions of higher concentration to regions of lower concentration. Diffusion. Molecular speed and temperature.